What's up guys, welcome back to a new video, and in this session we'll be looking at how to solve real-life problems on kinematics. This means problems about moving objects and predicting their final position, how long it took them to get there, and what their final velocity is. I will be going through these problems step by step, explaining the reasoning and all of the calculations along the way. As always, these problems start out very basic, but get progressively more difficult towards the end. So feel free to skip around according to your own level if you feel at the start that the problems are too basic for you. Before we start, I want to point out that these two formulas are the only formulas that you need to know in order to solve all of these problems, no matter how complex you can think of. Now, because this is not a theory video, I will not be going into these formulas right now, explaining everything about them, but they will get more clear during the exercises. The first exercise considers the following scenario. So you're just simply driving in your car at a speed of 100 kilometers an hour. This means around 60 miles per hour. The question now is, how much distance do you cover in 1 second? Well, what you have to do here is you have to convert this 100 kilometers an hour, you have to convert it to something meters per second, because at that point you know how much meters you cross in 1 second. What we have to do here is change this unit of velocity to this unit of velocity. To do this, we know that 1 kilometer is just 1,000 meters. And we know that 1 hour is 3,600 seconds. Basically, it's 60 minutes times 60 seconds in a minute. What we can do here now actually is simply fill this in this unit itself. So we have 100 kilometers per hour is equal to 100 times 1 kilometer is 1,000 meters divided by 1 hour is 3,600 seconds. So what we see here is that we have 100 times 1,000 divided by 3,600 meters per second. And we actually already have our result because we see that we have converted kilometers per hour to meters per second. And this is the conversion factor. So basically what we have to do now is just calculate this. So we get 100 times 10 divided by 36, because we can cancel these these 4 zeros here, meters per second. And this is basically just, if you use a calculator, 27.78 meters per second. And there we have our answer already. So we know that in 1 second, we cross 27 meters, give or take, which is quite significant. You just count 1 second and you're already 28 meters ahead of yourself. So this was a very basic warm-up exercise. Let's go to the next one. The second problem considers the same scenario. So we're driving at 100 kilometers an hour, or 60 miles an hour, which we now know is around 28 meters a second, and you suddenly hit the brakes. And it is known that in ideal conditions, for example on a dry road, cars can decelerate at a rate of 4.5 meters per second squared. The question now is how much time passes until you get to a halt, so until the velocity is 0. So again, you start from 100 kilometers an hour, and the question now is, how long does it take until the car reaches 0 velocity? The formula that we will need in this exercise is the following one. So the v of t, so the velocity at a specific time, is the initial velocity v0 plus a times the acceleration times t. So this is the formula that we will be using here. Which one of these quantities do we already know? Well, we know v0, that's just the initial velocity, the velocity that we are driving, and that is 100 kilometers an hour. And we know that this is 27.78 meters per second, which we calculated in the previous exercise. We know that A is equal to minus 4.5 meters per second squared. So our velocity decreases by 4.5 meters per second. Now, we actually already know v of t, because now we have to think, what is v of t? So the problem asks, at what time our velocity is 0? And the time in this formula is here and here. So this time is the one that we need to look for. And what is specific about this time is that the velocity is 0. So the velocity at this time should be 0. So we already know v of t, it should be 0. Given these numbers, we can now fill in this formula and rearrange it. So let's first rearrange this formula. And this is just basic algebraic manipulations. And if you're unsure on how to do this, because we want to rearrange it so that we isolate t, if you're unsure on how to do it, then I can refer to my previous videos of linear equations, so how to solve linear equations, where I go through these exercises step by step. So if we rearrange this formula, we get v of t minus v0 divided by a is equal to t. And t is indeed the thing that we wanted to have. And well, just to be complete, to get from this point to that point, we first subtract v0 from both sides of the equation, and then we divide by a. And that's how we get to this equation here. And now we can just fill this in. So we get v of t is 0 minus 27.78 meters per second, because that's our v0. And then we divide it by minus 4.5 meters per second squared. And let's look now how we handle the units, because in physics, we always want to solve problems using the units, because these units in the end we'll have to check out. Here we're looking for a time, so the units should be in seconds. So let's see how this works. We can cancel these meters, and then we can cancel one of these seconds here and here. And the second that is remaining in the denominator of this denominator, it just gets to the enumerator. So we indeed have seconds as a unit of time. So if we calculate this, then we get minus 27.78 divided by minus 4.5 seconds. If we use a calculator, then we get that this is 6.17 seconds. And this is our result already. So we know that if we are driving 100 kilometers an hour and we hit the brakes and we decelerate at 4.5 meters per second, it will take us 6.17 seconds to get to a halt, so to get velocity 0. Now a follow-up question to this is, how far would we have traveled in this time? So we know that we were traveling at 27 meters a second, which is 100 kilometers a second, and we are now coming to a halt in 6.17 seconds. But how far will we have traveled during this time that we were hitting the brake? To solve this one, what we have to do is use the formula x of t is equal to x0 plus v0 times t plus 1/2 acceleration times t squared. Why do we have to use this formula in this case? Because what we are looking for is a distance. So how far have we traveled in this time, which is 6.17 seconds? Well, x of t is the position after a specific time of a moving object. We are the moving object in this case, and we are traveling for 6.17 seconds. So what is x of t after 6.17 seconds? What do we need? We need x0, which is the initial position that we had, and we can take this to be 0. Then we need v0, which is the initial velocity, which we know was 27.78 meters per second. We need the acceleration, which is in this case minus 4.5 meters per second squared. Units are very important. And we need the time that we're looking, the time interval over which we are considering this problem, which we calculated in the previous exercise to be 6.17 seconds. Using all of this, we can simply fill in this formula and get a number for x of t, which we will do right now. So we get x of t, and t is 6.17 seconds, is equal to x0, which is 0, plus 27.78 meters per second times t, which is 6.17 seconds, plus 1/2 times a, the acceleration, is minus 4.5 meters per second squared, times, and now we have to square times, so it's 6.17 seconds squared. And let's see how the units now check out. Here we have second and second, which drops out, which can be cancelled. Here we have a second squared, and here we also have a second squared, because this second gets squared. And we are left with meter and meter, so the units check out. This becomes 27.78 times 6.17 meters minus 1/2 times 4.5 times 6.17 squared. And this is, if you run it through a calculator, 85.75 meters. And I even forgot here to put the units, and it's important to have these meter and meter. And this 85 meters is our result. What we did in this exercise, as a recap, is that we calculated that when we are driving 100 kilometers an hour and we hit the brake all of a sudden, which gives us a deceleration of 4.5 meters per second squared, it will take us around 6.1 seconds until we come to a full halt. And during this time, we will have traveled 85 meters. Let's go to the next exercise. This third exercise is quite a practical one. If we throw an object into a well or out of the window and we count how long it takes for this object to hit the ground, we can actually very easily calculate how deep this well is or how high the building is that we threw an object out of. How will we solve this exercise? Well, we know that t is 2.2 seconds. And we also know that v0 is 0 because we don't give our object an initial velocity, we just drop it. So it starts from 0 velocity. We also know that our initial position is 0 because we want to see how deep the well is or how high our building is. What we then want to know is x of t, where t is 2.2 seconds. And we know that our object accelerates at the acceleration of gravity, which is 9.81 meters per second squared. So these are our givens. How can we solve this? Well, just by using the formula that we already used a couple of times now, which is the formula that gives us an expression for what the position will be after a certain time t. At this point, we know that x0 is 0. We know that v0 is also 0, so this term also drops. And the only term that we are left with is this last term here, which only contains the acceleration and it contains the time that the object falls squared. So we can actually fill this right in. It's 1/2 times the acceleration, which is 9.81 meters per second squared, times the time squared. And the time is 2.2 seconds squared, which is 1/2 half times 9.81 meters per second squared times 4.84 seconds squared, because it's important to also square the units. And we see that for the units, these second squares drops, and we remain with the meters, and that's exactly the unit that we need for a height or a depth. And if we calculate this, we get 1/2 times 9.81 times 4.84 meter, which is equal to 23.74 meters. And this is our answer. So if we throw an object out of the window or we let it fall, then if it takes 2.2 seconds until it hits the ground, we know that it will have fallen 23 meters. And actually, we can approximate this 9.81 by 10. Using this approximation, we see that x is approximately equal to 1/2 times 10 times t squared. So what you have to do is just count the seconds, square it, and then multiply it by 5, and you will know how high it is. In this example, we had that t was roughly 2. So our approximate result would have been 5 times 2 squared, which is 5 times 4, which is 20. And this is quite close to the result that we actually had. So this is a very nice formula to get an approximate result for example, if you're walking and you find a well, you just drop something in, you count, you square the amount of seconds that you count, and you multiply the result by 5, and you know how deep the well is. Let's now go to the last exercise, which is very straightforward. So you shoot a handgun straight up. So the bullet goes straight up. And this is approximately, with a typical handgun, of around 300 meters per second. Now, the question is, how high will this bullet fly? So what will be the maximum height of the bullet before it comes down again? Again, what are our givens? Well, we know that V0 is 300 meters per second. This is the typical value of a bullet leaving a handgun. We know x0 is equal to 0. We know that our acceleration is just the acceleration of gravity, which is minus 9.81 meters per second squared. So this is basically what we know. Now, if we start with the formula, so x of t is equal to x0 plus v0 times t plus 1/2 times the acceleration times t squared. This formula will not help us at this point, because if we look at the givens that we have and the things that we need to fill in this formula, we see that we have x0, we have v0, we have a. However, we are missing t, and t is the time that it takes for the bullet to reach its maximum height. So if we fill in this t, then we can get our result, our x, our maximum height. So how do we get t? We get t by thinking, what makes this point special, this maximum height? Well, for one thing, it's the maximum height, but the other thing is that at this point, the bullet changes direction. It goes from going up to going down, which means that at this specific point, the velocity is 0. So we know that at the maximum height, the velocity is equal to 0. Using this information, we can utilize the formula that we already used in this session, which said that v after t, so this means the velocity after a specific time t, is equal to its initial velocity v0 plus the acceleration times this time period t. From this formula, we want to extract this t, and not just any t, we want to extract the t at which our velocity is 0. Because at this point where our velocity is 0, it means that our bullet has reached its maximum height, and so this t can then be directly plugged into this formula, so we can get x of t. We don't want any t, we want the specific t at which v of t is 0. And using this, we can rewrite this formula with v of t equals 0. And at this point, we can rearrange this formula to get t, which basically becomes t is minus v0 over a. And this formula gives us t directly, because if we fill this in, we get 300 meters per second, which is the velocity that the bullet leaves the gun, divided by minus 9.81 meters per second squared. And then we don't forget this minus sign in front, which comes from this one. Again, looking at the units, which is very important, we cancel this meter and we cancel 1 power of s, and this s in the denominator of the denominator gets to the numerator, which gives us as a result 300 divided by 9.81 seconds, which is equal to 30.58 seconds. So what does this mean? It means that after around 30 seconds, our velocity reaches 0, which means that our object, our bullet, is going from an upward direction to a downward direction, which means that after 30.58 seconds, our bullet reaches the maximum height. Having this t, we can now directly fill it in our formula to find the maximum height. Let's do that right now. So we had that x of t is equal to x0, our initial position, plus v0 times t, plus 1/2 a times t squared. And now we actually have all of the information to fill in this formula, because we know t, which is just what we just found. We know a, 9.81 meters per second squared. We know v, which is 300 meters per second. And we know that x0 is 0, which gives us 300 meters per second times 30.58 seconds plus 1/2 times minus 9.81 meters per second squared times 30.58 seconds squared. Let's now first look at the units so that we are sure that we are not making any mistakes. We see that here this second and this second cancels out. We have here second squared, and this second here gets squared as well, so it drops out. And we are left with meters and meters. So our unit will indeed be just meters, which is fitting for the height or the position that we are looking for. So the units check out. Let's now simply calculate the number. So we get 300 times 30.58 plus 1/2 times minus 9.81 times 30.58 squared. And this entire thing has the units of meter. Using a calculator, we get this first term 9,174 meters minus, because we should not forget this minus sign here, 4,586.8 meters, which is equal to 4,587.2 meters. And this is actually our final result. And to recap, what we did here is that when we shoot a handgun straight up, the bullet leaves at 300 meters per second. After 30 seconds, 30.58 seconds, it reaches velocity is equal to 0. So after 30 seconds, the velocity is 0. This means that at this point, the bullet is at its maximum height. So then we calculated the height after 30 seconds, and we got 4,587 meters. So it's actually baffling that if you fire a handgun straight up, that the bullet will go 4,500 meters high. One thing I do want to stress here is that in these exercises, we didn't take into account air resistance. For example, with the bullet, we know that the air resistance actually cuts this distance in half. So the bullet will travel between 2.5 and 3 kilometers high because the air drags the bullet down. Nonetheless, this is still a tremendous height for a bullet to travel. And this brings us to the end of this video. As always, I hope you learned something, and if you have any questions, just let me know in the comments below. I will respond to all of them. If you have any suggestions for future content, also let me know and I will most certainly make a video specifically on what you suggest. If you like this video and you want more people to find these, feel free to give it a thumbs up. And if you want to get notified by future videos, then just subscribe. And with that, I'll see you guys in the next one. Bye.